So previously we practiced solving equations when variables were on both sides of the equal sign. And so what we'll add on in this lesson is you can see on the left side of the equation over here that there is a distributive property to do. And we know that this is distributive property because we have two terms in parentheses, and those terms are separated by an addition sign. They could also be separated by a subtraction sign. So as it says in the paragraph at the top, or the sentence is at the top, it says you may need to use distributive property to simplify one or both sides before we can get the variable alone. So if we take a look at this example, you can see that we would need to distribute the 3. And remember, to distribute, we distribute by multiplying to each term in the parentheses. So the 3 gets distributed to y, and that's 3y. The addition symbol drops down, and now we distribute the 3 to the 7, and 3 times 7 we know is 21. And then that equals 10y. Now this looks a lot like what we did in the previous lesson. So if you're somebody who likes to cut it down the middle, you could cut it down the middle. And just like yesterday, you have to pick a side that you want to collect the variables on. For me, I think it's easiest to get rid of the 3y's here on the left. So I'll do that by subtracting 3y's. And when I subtract 3y's on the left side, I also need to subtract 3y's on the right side. Well, on the left, 3y minus 3y, we know they cancel, turn into 0, nothing there. So on the left side, it says 0 plus 21, which I know is just 21. On the right side, 10y's minus 3y's, I know is 7y's. Again, our job is to always get the variable all alone. So to do that, 7 times y, the inverse is to divide by 7. So I'll divide by 7 on both sides, and 21 divided by 7 I know is 3. And 7 divided by 7 I know is 1, so 1y is just y. So I'm almost positive that y should be 3. Now you'll notice on the right it says to check it. So to check it, I'm just going to substitute. I have my original equation, 3 parentheses y plus 7. But if I think y is 3, I'm going to substitute in that 3 that I just solved for earlier. Plus 7 in parentheses equals 10 times y. And we thought that y is 3. So we'll substitute a 3 there. And then we'll just follow our normal work for order of operations. 3 plus 7 is 10. And on the right side I have 10 times 3. So on the left, I know on the left side 3 times 10 is 30. And I know on the right side 10 times 3 is also 30. I just proved that y is 3. And I proved it by substituting. So this would be a good one for you to try. Take a look at it real quick. Notice it looks like there's distributive property on both sides. Now would be a good time to stop the video, give this a try. Once you think you've got it, turn the video back on, and I'll go through step by step with you. Alright, so hopefully you've tried this, and like we said, on the left side there's distributive property, and on the right side there's distributive property. So there's work to do on both sides. On the left, 6 times g I know is 6g. The addition symbol drops down, and 6 times 3 is 18. So we've got the left side as simplified as it can be. On the right side, negative 2 times g is negative 2g. The addition symbol drops down, and then negative 2 times 31 is negative 62. So I've got both sides simplified. Now again, I have to pick a side, and I want to take the variables off of that side. And again, it doesn't matter, just like we went through yesterday in the last lesson. You get to pick whatever side is easiest for you. For me, I'm going to get rid of these negative 2g's on the right side. And there's a couple ways you can think of that. You can say, I'm going to subtract negative 2g. Well, we know subtracting a negative is just a big plus, adding a positive 2g. So negative 2g plus the positive 2g, we know that cancels or turns into nothing, into 0. And whatever we do on one side of an equation, we've got to do on the other side. So on the left side, 6g's plus 2g's are 8g's. The plus 18 drops down. On the right side, that left us with 0 plus negative 62, which is negative 62. So I've now collected all the variables on one side. I want to move the constants, that's the plain numbers. I'd like to get the plus 18, the positive 18 off of the left side, and I do that by subtracting 18. So I got to subtract 18 on both sides. That leaves me with 8 g's on the left. And negative 62 minus 18. Negative 62 minus 18. That's an old problem. Negative 62, that's the same as saying plus negative 18. So I know that equals negative 80. And we're almost done. I know I should be able to divide both sides by 8. So that gives me g is equal to negative 10. I'm almost positive that g is negative 10, but I'm going to go over into the open space and check it. That's why it says to check it. To check it, we substitute. We write down the equation, but any place we see g, we thought that g was negative 10. So any place we see a g, we're going to change it into a negative 10. So in parentheses here, I've got negative 10 plus 3. On the other side, negative 2. In parentheses would be negative 10 plus 31. And if we follow the order of operations, we're going to work in parentheses first. Negative 10 plus 3 I know is negative 7. I'm going to take that times 6. On the right side, I've got negative 2 out of parentheses, but in parentheses, negative 10 plus 31 is 21. And let's see if this works out. On the left side, 6 times negative 7 is negative 42. On the right side, negative 2 times positive 21 is negative 42. It checks out. I proved that this worked by using substitution. So how can we take this a step further? Well, if we look at this, kind of a difficult problem if we don't read it through carefully. So let's look at all the pieces. We've got car A, and car A is traveling at a steady rate of 50 miles per hour. Now, that's probably not realistic, but we're going to pretend that it's going exactly 50 miles an hour. And remember what that means. That means each hour it travels 50 miles. And then we've got car B. A couple important things here. Car B leaves 1 hour later, and it's traveling at a steady rate of 60 miles an hour. Our question is, how long after car A leaves? How long after car A leaves will car B catch up? There's a couple ways you can think this problem through. First, we could set it up as an equation with variables on both sides like we just practiced. So we could talk about car A over here on the left side, and we could talk about car B over here on the right side. Car A, I know, is traveling 50 miles per hour. That's its rate. Well, I don't know how many hours car A was on the road, so I'm going to say times t. 50 miles an hour times however many hours. I don't know if it was on the road for 1 hour, 2 hours, 3 hours, I'm not sure. Car B, I know, is traveling 60 miles an hour. I also don't know how many hours car B was on the road, but I do know this. Car B was on the road for an hour less. So what we can do is we can say, okay, T stands for the time car A is on the road. So car B was on the road T, which stood for the time that car A was on the road, but 1 hour less, so we'll subtract 1 hour. Now this looks a lot like what we just practiced. On the left side, there's no simplifying to do, that's just 50t. On the right side, we've got 60 and then distributive property. So we're going to distribute that. 60t minus 60. As always, pick a side to get rid of the variables. I'm going to take the variables off of the right side this time. There's 60t there. I'm going to take away or subtract 60t. And 50t minus 60t I know is negative 10t. And on the right side, that would leave me with 0 minus 60 or negative 60. And we can wrap that up by dividing by negative 10. We know those cancel, leaves us 1t, and that would be positive 6. So the time would be 6 hours. Now let's go back up and answer the question. T stood for time that car A was on the road. The question was, how long after car A leaves will car B catch up? It would be 6 hours. 6 hours after car A leaves. Now that can be a little confusing, so another idea that some people choose to do is to draw a little diagram to help them. And they go like this. They say, well, here's car A. And car A is going to travel 50 miles an hour. And this will be a column for time, and this will be a column for car B. And we know car B is traveling 60 miles an hour. Well, after 1 hour on the road, so the time is listed in hours, after 1 hour on the road, car A has gone 50 miles. Car B hasn't gone anywhere after 1 hour of car A being on the road because car B is going to leave 1 hour later. So car B is getting ready to leave right now. So after car A has been on the road for 2 hours and traveled a total of 100 miles, car B has now finally traveled 60 miles. And after another hour, I know that car A has traveled 150 and car B has traveled 120. And after another hour, I know that car A has now traveled 200 miles and car B has traveled 180 miles. After another hour, I know car A has traveled 250 miles and car B has traveled 240 miles. After one more hour, I know that car A has traveled 300 miles and car B has also traveled 300 miles. So again, we still got the same answer of 6 hours. So again, what we need to make sure we do anytime we have problems like this is simplify each side by doing distributive property. Then you can pick a side to collect the variables on. Good luck.